So today we're going to talk about how to influence fog compliance. This is subtitled Stool Talk, which is a little bit different than some of you might be used to, because we're talking about a stool that you sit on. And in particular, we're going to talk about the three legs of the stool and why, with a stool, it has to have all three legs to be effective, right? No one wants to sit on a one-legged stool. And I believe for maximum fog compliance, there are three key elements that need to be working together in harmony. And it's kind of easy, especially from the manufacturer's point of view, to oversell one of those elements over the other two. And so I want us to take a step back today, look at the three elements, see how they're going to work in harmony to give you guys maximum compliance with the FSEs in your area. So first we're going to start with technology. This is probably the most obvious one. It's the one that many people in my position would talk about because it's the one that we kind of know. Our company makes grease interceptors. And so predominantly we're going to be talking about grease interceptors when we're talking about technology. So gravity grease interceptors are what everyone is comfortable with. How many of you have seen a gravity grease interceptor installed in your area or have approved one or inspected one? Show of hands. Great. Awesome. By the way, this is going to be interactive. I have a education background. I used to teach high schoolers. And so if I don't get good interactivity or good questions, if I'm not getting interrupted, I start to talk more slowly. So please, at any point in time, feel free to raise your hand, ask a question. I don't have a slated time for Q&A because I expect it to happen as we're talking through this. All right? So gravity grease interceptors, these are really, really common. These are, many of them, repurposed septic tanks. Anyone that was in Ken's talk on Monday would know that. Excuse me. These are sized by volume, which means they can get quite large. They are extremely common. They're typically 1,000 gallons or larger. So 1,000 gallons is usually the small ones. And these are not tested for efficiency, and as such, there's really no good standard for comparison. Now, there are a number of brands that make these, but there's not a great way to say that this one is better or different in any way than another one. This is kind of heavy stuff, but they can lead to saponification and cause clogs downstream due to calcium deposits from breakdowns. There's a lot of calcium in concrete in particular, and it can cause hard blockages in your downstream sewer system. And then these abide by the 25% rule, which we'll get into in a minute. So this is a standard cutaway of a gravity grease interceptor. You'll see many of them have multiple chambers, and this is to help with the capture of grease and the retention of grease. So grease interceptors should serve two functions. They should capture grease coming in, but then they should also hold on to grease that they've caught. Some of them won't have a baffle. Some of them are just one big open chamber. Some of them will have multiple baffles. Excuse me. So the most common material these are made out of is going to be concrete. Concrete is really cheap to manufacture. Concrete is what septic tanks have been made out of for a long time. And so concrete is what you probably have seen if you have approved these or inspected them in the field. But we also see these made out of steel nowadays, which concrete and steel are of the materials that are currently being used in production, the ones that will break down and corrode because of the nasty environment that is a grease interceptor. Fiberglass is pretty common. It's going to have a long shelf life, but when it does break down and corrode, you've got fiberglass to deal with, and so it can be a mess if they ever do break. They're also a little bit more delicate in shipping. Polyethylene is what we're seeing some manufacturers moving to now. So this is an example of a steel tank. This is a 5-year-old steel interceptor. You can see the baffle wall is totally corroded and had to be replaced. This is a concrete interceptor that was found leaking. Now this particular one, the city was going through a new code enforcement. This is in Miami-Dade County, Florida. The code enforcement required a changeover in their plan review process. Nobody could understand the new plan review process, so it took 4 months for them to get this replaced. Meanwhile, the Olive Garden where this was installed was having to have 3 pump trucks per day come and put their hose straight into the inlet side of the interceptor to capture all of the effluent from the kitchen. Cost them over $350,000 in the 4 months it took to get through plan review. So what kind of testing do these undergo? The hydrostatic water test. They fill it up with water, and if it hasn't leaked too much in 24 hours, it's good. I mean, you don't want it to leak too much, but this is the only test and certification that that gravity grease interceptors have to undergo. They are assumed to work. They work on detention or retention time, depending on who you're talking to. The challenge here is, the idea is that you have this big tank of water. When the kitchen effluent enters in, there should be some volume of water enough that the grease can rise and be separated and captured before it reaches the outlet side of the interceptor. Why this is kind of up for debate is no one can really agree on how long is the right amount of time. So looking across codes, you'll find codes that say 30 minutes is the right amount. You'll see codes that say 4 hours. You'll see codes that say it has to be able to hold the same volume of water for 24 hours worth of kitchen effluent. And so, again, because there's no standard and there's no certification process, it's kind of just anybody's guess as to how long it actually needs to be effective. And then with gravity grease interceptors, you also run into the 25% rule. This is where inefficiencies come into play. So there is turbulent flow inside of a gravity grease interceptor because you have this big empty chamber, you have settled colder water coming in contact with hot water from the kitchen fixtures. When that happens, it becomes turbulent. There's no baffle structure, even in interceptors, gravity grease interceptors, with a baffle wall. This issue is actually worse than ones without. You heard Ken Laux the other day reference the WRF study. This was done by NC State University and Joel DeCoste. And they found that without a baffle wall, it actually performed better. But what can happen is you get this turbulent effect, and the deeper the grease layer is built towards the flow of that turbulent water, the more likely it is to lose already captured grease. And so you have to pump these out when they're 25% full of grease, which means 75% of a 1,000-gallon concrete grease interceptor is just holding water so that it can work properly. So if any of you are from a district where water is a premium resource, a lot of your water is just sitting in the ground so that the gravity grease interceptors in your district can work. So next up are hydromechanical grease interceptors. These are newer. The gravity grease interceptors are 100 years plus old technology. These are 40-ish years old, have been really engineered over the last 20 years. So hydromechanical grease interceptors are usually constructed of polyethylene steel or fiberglass. There are not any hydromechanical grease interceptors made of concrete that I'm aware of. These are sized by flow rate. They are not sized by volume. And they are typically less than 300 gallons in volume, though there are a couple of companies that are coming out with ones up to 1,000 gallons. So instead of being full when they have 25% of their volume as grease, these can hold some of them as much as 90% of their volume with grease, which means you can hold the same amount of grease in a much smaller interceptor. So these use baffles and flow path to capture grease and not the detention time. So it is a different way of performing the same function that doesn't require as much volume. These have been engineered for grease capture and for grease retention. As such, these are certified under a couple of different certifications. Most are certified under the ASME A112.14 or PDIG 101. And they are tested for grease removal efficiency, and most of them are tested to maximum grease capacity. So most of these are tested to the failure point. I'll talk about that in a minute. So this is a cutaway of what one looks like. You'll notice it doesn't actually look all that different from a gravity grease interceptor. There is engineering that has gone into maximizing the flow path, making sure that the baffles are in the right place, making sure the inlet and outlet are appropriately oriented, that allow this to operate at a higher level of efficiency. So let's talk about the testing process. So ASME, PDI, and CSA, these are three testing standards that are all pretty much exactly the same. This is how all hydromechanical grease interceptors that are certified are tested. You might find something online that is just a box that has no certification. That absolutely shouldn't be approved, but any of the large manufacturers are going to have these certifications. So here's how the test is done. We have a couple of sinks that we fill with water and a known amount of liquid lard. It then drops 10 feet into the grease interceptor, and we capture all of the effluent that comes out of the grease interceptor. We then measure how much liquid lard has escaped the interceptor and compare it to how much went in, and that allows us to calculate the efficiency. So this is a test rig. This is our test rig in North Carolina. You can see here we've got sinks up the top, goes through the grease interceptor, and then there's a skimming tank where we capture any grease that has escaped. So you have never seen chunks of lard as big as we have in our freezer at R&D. So this is being liquefied. It's being heated to between 150 and 160 degrees Fahrenheit. There it is, liquidy. We add water to 2 sink compartments between 150 and 160 degrees Fahrenheit. And we will add the lard to one of the 2 sink compartments, and we're going to be alternating. Now, the amount of water that goes into the sink compartments is double the tested flow rate. So let's say we're testing for 100 gallon per minute flow rate. We would use 200 gallons of water per test, and we use 1 pound of lard for every 20 gallons of water. So in this one, we would use 20 pounds of lard. It then drops 10 feet through the interceptor, and we're capturing everything that comes out on the other side. We then skim off any of the liquefied lard that is going to be floating on top, and we're capturing that, and then we're going to pour it into a separatory funnel. And this is just to remove any extra water that we skimmed up. We then measure those, and we take those measurements, and we're going to calculate based off of the known amount of lard that went in, how much was able to escape. And so success looks like the unit has passed with the capacity goal, which is 2 times the GPM. So a 100 gallon per minute unit has to hold 200 pounds of lard. Or 2 successive drops are less than 90% efficient. So 90% is the baseline efficiency. Or any 1 incremental drop is less than 80%. So if there is just a failure, then the test is over. And we do this for 12 drops. And the efficiency is the grease added minus the grease skimmed over the grease added. And so with these tested units, you can ask, hey, what is your test results? You can see here that they may have they'll have the flow rate, their capacity. Now these are the minimums. Most of the hydromechanical interceptors on the market now will be tested to failure. So for instance, our 100 gallon per minute unit has to hold 200 pounds of grease. It holds 1,826 pounds of grease. So, the minimum may be wildly different from what the reality is. So there are test reports. So if you have any question about, hey, how does a Trapzilla compare to a Shear, compare to an Endura, compare to a MyFab, you can ask, hey, I'd like to see the test reports. Let me see the actual performance. And so you can compare apples to apples. All of these devices have a flow control, almost all of them have a flow control, and this is a part of the test. They ship either integrated into the interceptor or as an add-on piece. Now, Ken brought up solids. Solids can be a problem for these hydromechanical grease interceptors. They have been engineered to maximize grease capture. They haven't been engineered to maximize solids capture. And so if you have a facility that's going to have a lot of solids, a lot of rice, buffet, something like that, we recommend installing a solids separator in front of the interceptor. They come in a variety of forms, but they're going to capture all the solids before the grease and water pass on into the grease interceptor. There's another one. So let's look at the gravity grease interceptor versus hydromechanical. In terms of size, these are to scale. So you have a gravity grease interceptor on the left, hydromechanical interceptor on the right. The one on the left has a 1,000-gallon total volume. The one on the right has a 274-gallon volume. The one on the left is full when it's at 25%. The one on the right is full when it's at 91%. They hold almost the exact same amount of grease. The one on the right holds 1.3 pounds less grease, gallons less grease than the one on the left. But you could fit about 3 of them in the same footprint. So any of you that are living in or working in a downtown area, if you've got space constraints, hydromechanical grease interceptors can fit where gravity grease interceptors can't, and they can offer the same or sometimes even more grease capture. So, you have scalability as an option. Multiple units can be installed in series or in parallel to create higher flow rate situations or higher grease storage situations. Excuse me. These are two examples. This one on the left has 2 solids interceptors and 6 gravity grease interceptors. This is the equivalent of a 6,000 gallon concrete gravity grease interceptor in a much smaller footprint. On the right is a system that actually splits. It splits twice. So this is capturing 400 GPM of flow into these 4 sections of interceptors. This is installed at the Contemporary Resort in Orlando, Florida, at Disney World. They needed something to capture effluent from the 14th floor, but they didn't have any space because they're essentially landlocked. You build an amusement park, you can't expand if you don't have a space. So how do we size these? Well, we size them by flow rate first. Right? They are certified to a specific flow rate. We got to size them by flow rate. But then, if any of you were in Ken's talk, he talks about grease production, and this is very important. Now, these numbers, excuse me, these numbers are from ASPE, and these originated with a third-party study for grease production, and they looked at, they measured the grease production for a number of different types of restaurants, put them into a chart, and said, this is pretty reliable, our best guess of how much grease will be produced per meal for a given cuisine type. So at this point, all of the big hydromechanical grease interceptor manufacturers have a sizing tool that take these numbers into consideration, because we realize just sizing on flow rate's not good enough, right? Because if you have a low flow rate, but you're pouring grease down the drain every day, then the interceptor is going to be full long before their pump out. And we don't want that. We know you don't want that. So everybody has online sizing tools that look at dimensions of sinks and grease production sizing to offer best recommendations for what system needs to be put in place. Now, also under the hydromechanical grease interceptor umbrella are these undersink boxes, sometimes called passive interceptors. These are or should be certified to the same standard. They usually are tested to, not tested to failure, because their failure is usually close to twice the flow rate. Right? So the box that we have or had outside was a 20 gallon per minute flow rate. It has to hold 40 pounds of grease. It's not going to hold much more than 40 pounds of grease and still pass that 90% efficiency mark, right? I don't know if any of you guys have these or allow your FSEs to self-clean them, but we found this shot on Twitter. This is the CEO of a culinary arts school for troubled teens. They bring them in and they teach them these skills. And so she, I don't know if it's diplomatic, if she lost the straw jaw, but I see some have already noticed the gloves. So for the FSCs that don't want to have to do this but are allowed to self-clean, automatic grease interceptors are the solution. So automatic grease interceptors combine the efficiency and the certifications of hydromechanical grease interceptors with effectively daily pumping. So you imagine this large tank being emptied out every single day. You're not going to have a bypass because you're not having much, if any, grease accumulation. Most of these are designed to completely empty all of the grease contents every 24 hours. So at most you have 23.59 hours worth of grease accumulation. It's almost nothing. So let's look at these. They have a hydromechanical grease interceptor internal structure. So they have baffles, they capture the grease the exact same as the other HDIs we were talking about. So you unplug these. If you take out any of the electronic parts and put a flat top lid on it, it's going to work as a passive hydromechanical grease interceptor, and it will fill up until it reaches its capacity. These are also sized by flow rate. There are a variety of sizes to service single sinks all the way to a full facility. So there are some facilities where they might have a large system in the basement capturing the full kitchen. Sometimes one of these just goes right next to the pre-rinse sink. They also separate grease using baffles. They include a grease removal element, which is usually a heater, but the system doesn't need to be pumped to be emptied. They do require some daily maintenance. Most of them require less than 5 minutes a day of daily maintenance. It's pretty straightforward, and it does need electrical power. But these are also should be certified under the ASME and PDI certifications. So there's a number of different designs. Some are made out of steel. Some have a polyethylene interior. All of them, though, are going to have a heating element again, usually, and some sort of skimming function, and usually some sort of solids capture. Question? Yeah. So that's a very important piece. You know, just because you have something under the sink doesn't mean people aren't going to throw all the garbage down the drain. So this is just a cutaway showing exactly what that might look like. The heating element is going to heat up and liquefy grease that's been captured over the last 24 hours. Right? If it doesn't do that, it's going to be solid, and there's no way for it to skim it out. So the grease, once liquefied, is going to then connect to a skimming wheel. In this case, it sticks to the side of that skimming wheel, where it's brought up towards the top of the unit, scraped off, and put into a grease collection container hanging off the front. This can be emptied by being removed, and then there is a strainer basket on the inside. Excuse me. So these are usually on the floor in the kitchen. They can be in the basement as well. We don't recommend putting these in a vault in the floor. So these are not great if there's not a basement, but your code requires them to capture floor drains, because then there is a high likelihood they'll neglect the daily maintenance. And if that happens, it could overflow into the electronic components. So this is what the maintenance might look like. You're just going to take off that container on the front, pour it into the garbage or their rendering barrel, or mix it with kitty litter. This is really a code local issue as to how you would like for them to dispose of this. Some rendering companies will take this because it has been, in a way, dewatered and also pulled out from the other solids, and they find that they can still get some biodiesel benefit from this. They're also going to take off the lid piece and empty out the strainer basket. So the skimming portion, you might be thinking, well, this is great for a coffee shop or something. How effective can this be at actually taking grease out? This particular model, the one that we've had here, can take out 9 pounds of grease every hour it skims, and it can skim up to 4 times a day, which is 56 pounds of fog that can be removed from the interceptor, which is about as much as a bag of potatoes or the average 7-year-old. Is there a question? Great. So this is what a centralized system might look like. So maybe this is at a hospital in a basement. They might have this going directly into a 55-gallon drum so that it can be constantly capturing grease without requiring that daily touch from the kitchen. These are also great for rotisseries and combi ovens. Now, what do you guys do with that effluent? This can go into a unit like this, and all of the automatic units that are designed for combi ovens will have a supplemental water supply so that there's a balance between the water in the tank and the fat coming off of the chicken so that it rises to the top. If you don't have that, they'll fill up with fat because the only thing it's accepting is the fat from the rotisseries. All right, and then last, this is an honorable mention. Show of hands, does anybody allow dosing at the restaurant level, chemical or biological? Great, we'll skip it then. Almost no place does, and at best, it will clean out the grease interceptor and pass the problem down to their neighbor. All right, so back to the stool. The next leg of the stool is servicing. So servicing is going to be measured by things like grease depth, service frequency, separator inspections, camera line inspections, effluent testing, and it could include the degree of service the interceptor is receiving, the frequency of the service, site inspections, or sampling. Any questions yet? before we move on to the next leg of the stool. All right, slow to yes.
The performance report, is that something that's found on your guys' website, or is that something that you have to email to figure out? Just open information.
Yeah, great question. Question was, the testing reports, is that something that's just freely available information or something you got like behind a closed door? It depends on the manufacturer. Some manufacturers are very forthcoming with that. Some kind of tuck it away. The certifications themselves are publicly available, looking for actual test data. Some have it on their website, some have it behind closed doors. You can also find it on the IAPMO website. So IAPMO is responsible for the ASME testing, and they have that publicly available. And NSF does PDI testing usually.
And then did you say you guys only do 12 tests or 12 cycles with the sinks? Why 12?
Great question. So we do 12 drops of the sinks for the ASME and the CSA tests. PDI, we actually do 13. The certification is for twice the pounds of grease than the flow rate. So if you did 10 tests, you would have twice, right? So 100 GPM at 20 pounds each, it's going to hit that 200-pound mark after 10 sink drops. But we do 2 extra as a safety factor. So they're adding in a little bit of safety. We don't get to claim that safety. Really what they're doing is they're looking to see, do we fail immediately right away? And so if we fail on that 12th drop, we don't pass the test. So, one of the reasons for that is we want to make sure that there's enough capacity in there that even when it's full, a little bit extra. The PDI does 3 extra drops, which means that the actual capacity is even higher, but you don't get to claim any of those extra on the test. Good question. Any others? Gold star. All right, so servicing. You guys are going to be familiar with most of these. This is pumping. Oh, servicing. Let's talk about this for a second. So, technology is where you have the greatest level of control. Right? Your codes dictate what technology is and is not available in your district. And talking to many of you here, there is disagreement within your codes as to what is and is not allowed in your district. Right? Everyone has a different opinion. Servicing is where you have some control, but even less than the technology. Right? So now we're seeing a lower degree of control here. Some of you have built servicing control into your fog programs. Many of you that I've talked to this week have not. So pumping is a piece of control. Are they being pumped properly? Are the interceptors being pumped out to a standard that you're happy with? Do you feel like they've been completely emptied? Do you feel like they've been scraped down, sprayed down? And this is an example of a hydromechanical being pumped out. And this one has 2-stage, so solids are underneath that baffle. Here's a spray down that's being done. Is spray down something that the manufacturer recommends? Is a scrape down something that manufacturer recommends or allows? And that's going to depend on the material. They should all, once emptied, and they should be completely emptied, should be filled up, which is a lot to ask. It's a lot of water, especially for a gravity grease interceptor. But you've got this boat now that's empty, sitting underground. What's going to happen over time, especially if you're in one of the high water table areas? It's going to float up. So, that's a best practice. Inspection is something. You guys need to be looking, are the baffles in good working order? Does this tank look good? We've already seen these. Inspection also involves sludge judges or core samples. How many of you guys do this on any of the interceptors in your district? So about half, yeah. This is easy for gravity grease interceptors. You're looking, is 25% of it solids and grease? Yes, it's time to pump. For hydromechanical, every hydromechanical company is going to have some sort of chart like this that tells you what the depths are going to be for taking a core sample. Let's say this is the first shear unit or first Trapzilla unit you've ever seen in your district. You're probably going to want to take some core samples of that just to make sure, over the first couple of months, maybe every quarter for the first year, to make sure that you're getting what you would expect to see out of that and help set the FSC up on the correct pumping schedule. And there's going to be downstream sampling. Now, I heard some people talk about the GGIs having sample boxes built in. Some have manufactured sample boxes. In our experience with testing, it is always best to test downstream of the interceptor and not do outlet pipe testing. The test samples are going to be more reliable that way. Some of these companies, most of the manufacturers that have sample boxes have some that have a drop and have some that just have a steady flow through. And then based on what you're finding in the field, you should be adjusting what the FSE is and isn't allowed to do. Right? If the sample is coming up that something is not looking like you would expect it to, then maybe there's something else, another piece of this puzzle that needs to be examined further. If you encounter automatic units, you're going to want to see, hey, is the power on, right? These things are being pumped every day by a motor that has to have electricity. So if the power's not on, it's not working. You can test all of them. All of them have some sort of a test button. You press the button, and the inner workings are going to start up right away. You can see, hey, is this working? If it's not, then that's a red flag. You should inspect the solids area. You know, there are some areas on these things that they should be managing daily. If they're not, if you open it up and you see the solids is just packed full, like they've got fruitcake in there, that's a problem. That's a sign of neglect. Your codes should hopefully allow you the leeway to have some enforcement. If they have agreed to perform maintenance on something like this, and they are failing to do so, it should be the same enforcement as if they have failed to have it pumped. You can also inspect to see, hey, are the settings correct? Most of these systems are designed to take out all of the grease and just a little bit of water. We want to get all of the grease out. So if, like in the center picture, it's 100% water or 100% grease, then they probably haven't run it enough, and they're going to get grease buildup over time. If it's like the one on the right, where it's like no grease and water, like this is going to be, there's a place now in our town that's doing, they're doing pre-made health food, like they're packaging salads, and they do them all in one day. They do 1 day of food prep, they put them in the fridge, and they just sell them for pickup only through the day. If they were running this, and what happens is people think, well, there's not any grease coming out, so I've got to turn up the settings and make it skim more, right? Well, there's no grease coming out because there's no grease going in. So if you see this, they need to turn it down because they're burning out their motor. And then you should ask them to do a maintenance log, right? The control that you have here is more sporadic because you're not there every day for this. You can rubber stamp the technology going in, but once you do so, you're relying on them to do the right thing daily, especially if your codes don't give you some enforcement oversight. If you're asking for maintenance logs and you go in and the maintenance log says, hey, this was emptied today, and it looks like it's not been emptied for a month, then something is amiss and there needs to be some enforcement consequence. Questions yet? Cool. We will be here till about 4 o'clock, 6 o'clock, sorry. What? All right, so the last leg of the pretreatment stool is management. Now, this is where you guys have the least control. Best management practices have so much impact on what is actually happening inside of the grease interceptor and downstream of it in some cases, and yet you don't have a lot of control here. And so this is, I said when I started out that it's really easy as a product-focused company to say our technology is the best, and our technology is the whole picture, and if you put in our technology, you're going to have success. The reality is, any grease interceptor that is properly maintained is probably going to work. Any grease interceptor that's not properly maintained is absolutely not going to work. Doesn't matter how great the technology is, it's going to fail. Right? Best management practices in the kitchen is going to cause the very best, most efficient grease interceptor to fail if they've got the wrong practices. So how do we measure these? Well, these can be measured by things like downstream buildups. If you know that the technology is good, but you're still getting blockages downstream, something else is going on. High BOD, COD, and TSS. Are they just throwing junk down the drain? On-site blockages. On-site blockages. And this is going to include things like type of menu, washing equipment, cooking equipment, detergents and chemicals, grinders, staff training, staff audits, Have they put a dosing block on the wall? That they were told it's going to reduce their pumping frequency. All of these things are really going to have an impact on the fog control in your area. So, where do you start with this? All right, this is where you have the least control. So, our recommendation is start with training, education. All right? If they're not educated, they're absolutely not going to do the right thing, because none of the stuff that they need to do it comes naturally. Right? We know that fog is the last thing on any FSE's mind 100% of the time. You're standing in front of them, and it's probably not their priority, right? So, education is key, because if they don't know that there's a problem, if they don't know that there's a risk to their business, then they're going to do nothing. Now, even after they know that, they're probably not going to do the right thing, but it's a start. Many of the manufacturers, at least the ones that you would see at an event like this, hydromechanical interceptors, the guys that are trying to find market share from the GGIs that are just sitting back, pulling in money, they've invested in resources. There are resources that are online that are designed for FSEs. There are resources that are online that are designed for you to be able to hand off some of the education responsibility to the FSE. All right? Because we understand that their education is critical to their being successful, our products being successful, you being successful. So let's talk about some other management considerations and kind of change the tone and focus into some thinking about the bigger picture of this fog control and how can we be influential here without being too legalistic, right? So I don't know about you guys. When I think about fog, when I think about fats and oils and grease, I think steak. I have never had steak with a chicken garnish before last night. My goodness, that was delightful. Man. So let's think about how the kitchen BMPs might impact fog. This is an easy one, right? They have to have a grease interceptor because they're producing fog. This is obvious. Less obvious, the school. All right, what are some of the things that we need to consider when we're thinking about practices, servicing, maintenance, right? School is shutting down for months of the year. What does that do to the pH inside of the concrete interceptor? That was probably oversized to begin with, right? And they're not cooking much, and it's all cardboard and water, so it's going out the door, right? What about H2S? What's that doing while it's just sitting there stagnant for 3 months of the year? Or more if, there's a global pandemic and they've got to shut down. What is the shutdown procedure? Should this be something that's considered when sizing and choosing the right technology for this facility? What about ice cream? Sugar snakes. Sugar, huge problem. You get cellulose buildup. Looks like fog, but it's not. Kind of behaves like fog, but it doesn't. Getting high sugar and compounding that high sugar is low water flows. Not putting any water into the interceptor. Should that be something worth considering? These are places where automatic units probably shouldn't be installed, because what's the automatic unit doing once a day to the dairy that's in there? It's heating it up. You guys ever been around day-old heated dairy? It's not great. It's not fun. Hot dairy. Hospitals. Our hospitals tend to have centrally located kitchens, centrally located cafeterias, or prisons also. Are they, where is their interceptor going on site? When you've got the kitchen in the middle of the building, the further away from that you go, the more likely you are to get on-site buildup, and the deeper the interceptors have to go. So if there was a smaller solution that could be somewhere closer, maybe that would be a good fit. Coffee shops, they have solids like crazy, right? They're pouring all sorts of stuff down the drain, solids and sugar, and also generally low water flow. Pizza places, they've got yeast and dough, low sink flow. They're making pasta in their interceptor, right? And so, when you go there, they're making pasta, they've got low water, they've got really low pH. This is causing problems downstream, it's causing problems for their interceptor, which is 1,000 gallons because it's what the code says they have to put in. Whether or not that's actually a good solution for this FSE. Some people asked about this, we were talking about this last night at dinner. Who's familiar with the term ghost kitchen, or cloud kitchen, or virtual kitchen? Anybody? Nobody? All right, this is coming to any of you that are living in a high population area. If you're living in any downtown or working in any downtown area, these are coming. Ghost kitchens, cloud kitchens, virtual kitchens are all names for basically the same trend. So the trend looks like this. This was coming before COVID. It has escalated now. We have businesses that don't want to have to pay for the real estate to have a dining room because most of their food is takeout anyway. And now everyone's using Uber Eats or Postmates, delivery services. So why would they bother having a dining room when they can just have a small kitchen in a warehouse with 7 other small kitchens in the warehouse? Now, the warehouse, which was never designed to be a kitchen, doesn't have the plumbing infrastructure for that. And then the Uber driver can go and they can pick up the food from the virtual food court. Right? They go and they get 7 deliveries all at once from the same location. Or you get kitchens, you have restaurants that maybe the restaurant has been struggling because of marketing and branding, and no one knows who they are. So what do? They reinvent themselves on the internet, because anyone can do that. So now our little burger shop is now, the big burger shop is now also Mom's Burgers. It's now also Healthy Burgers. It's now also burger with the chicken on top, right? I'm now running 4 businesses virtually out of my 1 store footprint, which had a grease interceptor that was sized for how many burger places? 1. But I'm doing all of this via delivery services, via online pickup. So I've now quadrupled my fog load without changing my interceptor. So these have become much more prominent the last few years because people aren't going to the store in person anyway. So who cares if it's got 4 businesses in it? Or who cares if they have a store footprint anyway? Be on the lookout for these, especially if you're in the more built-up population-dense areas. You can look it up. Again, ghost kitchen, cloud kitchen, virtual kitchen. There are 3 varieties of kind of the same idea. Last one, grocery stores. A lot of grocery stores they already have an interceptor, but now they're adding a kiosk to the front of the store. And how are they connecting that kiosk? What are they connecting it to? Are they running a line 300 yards through the store to connect to the interceptor that might be out back? Or is it a reasonable approach to have something smaller for that kiosk? Treat that as a separate grease producer, fog producer. So, this is the last section of what I'm going to talk about today. Before I get into that, any questions about what we've already talked about? .4:30 it is. All right. Isolation and containment. Isolation and containment is an idea that maybe for some of your FSEs, the best solution for them is not a one-size-fits-all technology, but it's multiple technologies that allow for an optimized system for what they're generating. All right, so this is a case study. This is J.C. Holdway. This is a, what do you call that? Wasn't who's the famous? James Beard, award-winning chef in Knoxville. This is his corner building. They had no place for an interceptor, but he was coming into town and convinced the city to let him install a hydromechanical unit in their basement. Their effluent testing, so they had a limit of, their limit was 200 ppm. You can see 200 is, well, it's right here. They're all over the board, right? All over the board, and the city was taking a one-point failure approach. They said if it's over 200 once, we're no longer doing this. They were looking at it as a case study. They were uncertain this was the first hydromechanical unit in their city, and they said, yeah, we don't know about this. J.C. Holdway reached out to us and said, hey, is there anything that you guys can do to help us out? So this is a standard kitchen, pretty standard kitchen setup, right? They've got their outside interceptor, or in this case it was inside, but their main interceptor, and they've got some grease in their 3-comp sink. There's some poisonous emulsified grease in their dishwasher. Gotta watch out for that. And then the majority of their grease is coming from the pre-rinse sink. Right, by our estimate, about 75 to 80% of the grease is coming from the pre-rinse sink. So let me know if this tracks with you. So the fog from the 3-comp sink is going down the drain and is being captured by the interceptor. Fog from the pre-rinse sink is going down the drain and being captured by the interceptor. And then the emulsified fog from the dishwasher, depending on the type of interceptor, is going down the drain and being either captured or maybe it's escaping, depending on the interceptor. Right? Emulsification requires two things. It requires a detergent, which is going to make the fog behave more like water in the flow of water, and it requires a shearing force. The fog has to be ripped apart into smaller globules so that the detergent and the water and the fog can kind of hold hands and have a party. And now, emulsified fog is behaving more like free-floating water. Right? Is this how an interceptor system works and all the stuff in the kitchen? Does that track with anybody? Yeah?
What kind of food do they serve?
Fancy. Not a plate. Fancy food. American fare. Did that not look right, that process, to anybody? Good. All right, so here's what's happening inside either the pre-rinse or the 3-comp. Pre-rinses, depending on who's in the kitchen that day, will either have impounded flows or they're using the spray wand, right? In either instance, how much flow is helping the grease? If they've got an impounded flow, where's the grease in the sink? It's at the top, right? The sink is acting as a grease interceptor. The grease doesn't know to do anything but float, right? It doesn't care what container it's in, it's always floating. So the grease is floating at the top. Or if they're using the spray wand, how much flow of water is helping its journey down to the interceptor? Not much. It is just meandering, it's taking its time. It's going on a slow walk down to the interceptor. And so where is that likely to be as it is slowly making its way down? It's going to be right here. If it makes its way all the way down to the interceptor, it's going to be kind of hanging out in the inlet. Right? Maybe it's in the water here, maybe it's made its way all the way down the pipe and it's hanging out in the water, but it hasn't even made its way into the chamber portion of the interceptor. Because there's been no water to push it down the 3 to 6 feet, depending on how tall it is, down into the separation part. So it's actually already kind of pre-separating because it's separating there. So the majority of the grease is coming from the pre-rinse, right? So the 3-comp sink drops. They're dropping that, and maybe some of the fog is kind of meandering its way down there because maybe this one was not an impounded flow. And they drop the pre-rinse, and the pre-rinse has a long journey with no water flow pushing its way down. And so it's hanging out in the pipes. And then what happens next? The dishwasher. And what do we know about the dishwasher? It's probably hot, which is good for separation, but it also makes it easier for mixing. And I believe someone even said it in Ken's presentation on Tuesday. What can cause a shearing force? The jets can, but what happening here can cause a shearing force? Turbulence in the pipes, right? The plumbing itself can be the impetus for a shearing force. And so what we discovered was happening next is the dishwasher discharges with very little fog in it, but what is it doing? It's emulsifying some of the fog that's hanging out in the plumbing. And so there's greater fog loss downstream than there ought to be because of this. And so here was the solution we came up with. We put in a prototype emulsion fighter, right? This literally was just a second sink, basically. It was a holding tank. It could have been a 5-gallon bucket. So here's what happens. The 3-comp sink drops. Later, they're doing the pre-rinse. The pre-rinse drops, and all of the water gets contained for a little while. And it's just hanging out there. So if they're doing the spray wand, there's now more water that's actually going to help flush the system down. And if not, it's just sitting there. And then the dishwasher discharges. Well, there's not this big mess of fog hanging out in the pipes to be emulsified. So the dishwasher discharges. Maybe that dishwasher discharges escapes the outside interceptor. But then the prototype emulsion fighter is able to release all of the fog, all of the water in one drop. And if it takes its time getting to the interceptor, it doesn't matter so much because the dishwasher has already discharged. So, did I not put it in here? It dropped by over 120 ppm. It dropped the outlet, the effluent ratings, just by doing that. Right? This is an instance where behavior impacted the sewer system. So when we talk about containment, we said the outside interceptor, the main interceptor. This is containing everything. This is capturing everything that might make its way down there. Isolation is happening up here. Now imagine if this wasn't just a box holding stuff. Imagine if it was something like an automatic grease interceptor, and where it was taking all of the fog out of the system completely. Right? Here's what happened. Something happened in Miami where they found over half of their FSEs had a compliant interceptor, but their numbers were out of compliance. They made them rip those out, put in brand new interceptors with a higher efficiency rating. But what if instead they had put something like a small automatic interceptor under the pre-rinse, helped the system out? Right? With the two things working in harmony, the city really didn't care about what's going on inside. What they care about is what's going to sewer. But if what's going to sewer is being helped out by either kitchen practices, because if you're educating them, or by an in-kitchen interceptor, it's a different approach. And so, if they put one here, now they've got a system of things all working together. Oh, here's a picture. Look at that, big drops. So isolation containment is this idea that you isolate in the kitchen, you contain outside, and you can have a better system working overall. In summary, it's not 4:30 yet, but it's fine. In summary, your influence on fog control needs to hit on each piece. You need to be focused on not just the technology, not just on the servicing, not just on the management, because all these have to be working together. If they're not, there's going to be failures in the system. And so I have for you an awesome summary, but I don't expect anyone to see this, not even those of you in the front row. So if you would like this summary, this was a blog post written by the founder of our company, who's now head of R&D and has a blog specifically for pretreatment officials. This whole presentation was inspired from this blog post. You can find it and download it right here. Pull out your phone, scan the QR code with your camera. It'll take you there, and you can get a copy of the post summarizing a lot of things we talked about, and also this great picture showing the different degrees of control on this 3-legged pretreatment stool. I'm going to leave this up for a minute. My name is Seth. It has been great chatting with you guys today. And that's it. I'm done.